Thank you for the opportunity given. I can present the result of our research at the third Borobudur International Symposium 2021. The title of our presentation is Geomodelling of Asphalt Deposits using the borehole correlation method in Butuan Island, Southeast Sulawesi. Written by Victor Pangihutan, Irfan Marwanza, Taat Tripuryono, and Mas Agus Ahmad Azizi from Department of Mining Engineering, Universitas Trisakti, Indonesia. As for the one who will present is Irfan Marwanza, should be Victor but unable to attend due to illness. Outline of this presentation, I will start with an introduction, research methods, results, and discussion, and close with a conclusion. Well, I will start with an introduction. Asphalt deposits of Butuan Island, SE Sulawesi, Indonesia have been known since 1920s, and it is the only natural asphalt deposits mined in Indonesia. The deposits contain 15 to 35% asphalt or bitumen, making reserves of 100 to 132 million tons of asphalt, making the world-class scale. It has been used mainly for road construction and maintenance, but however, due to some problems, the use of Butuan asphalt is still minimum. Geomodeling. Geologic modeling or geomodeling is the applied science of creating computerized representations of portions of the Earth's crust based on physical and geological observations made on and below the Earth's surface. Geomodeling is commonly used for managing natural resources and natural hazards and quantifying geological processes with main application to oil and gas fields, asphalt, groundwater, aquifers, and ore deposits. And also, geologic models help define the volume and concentration of minerals to which economic constraints are applied to determine the economic value of the mineralization. And mineral deposits that are deemed to be economic may be very developed into a mine. Now we jump to asphalt definition. Asphalt, also known as bitumen, is a sticky, black, and highly viscous liquid or semi-solid that is present in most crude petroleum and in some natural deposits. It is a substance class as a pitch. This presentation discusses geomodeling of asphalt deposits using the borehole correlation method in Butuan Island, SE, Sulawesi, Indonesia. Now, on our right map, this is the geological map of Butuan Island showing distribution of exposed rock units, occurrences of the petroleum seeps, and area of asphalt deposits. And on our left side, we got structural map of Muna and Butuan Island showing imbricated thrust as responses to collisional tectonics by Bond and Lifshitz 2004. Now, the mechanism of the occurrence of natural asphalt until now not known for sure. Some theories how to form natural asphalt, among others, according to Abdul Rashid 1996, as follows. A, the way the overflow occurs in three shapes. The first shape is spring. Asphalt liquid form in the earth come to the surface through fissures, fractures, and faults. And then 3, lake. Liquid asphalt flows through the surface earth through cracks or faults, then settles in the basin. And the last one is seepage. Asphalt contained in rock then flows into lower due to pressure surrounding material or due to heat sun. B, asphalt impregnation in rock. Impregnating rock, asphalt that is liquid flowing and enter the pores of the rock through it. So that is unite with the rock where the asphalt flows. And C, filling vein. Liquid asphalt flow through the fold of the finally fill the fold until it is shaped like a vein. Asphalt quality standard. The standard test method used in this inspection is SNE 0636401994, and the standard value of bitumen content that has been determined to meet the market standards of Butuan asphalt is 18% to 24%. Then an inspection of the water content is carried out to determine the amount of water contained in the asphalt, which aims to determine the exact amount of water content contained in the asphalt and determine the relationship between the water content and the total weight at the time of sales contained in the asphalt. The standard used in this test is SNE 0624901991, and the standard water content value that has been set is a maximum of 16%. This slide contains the research method or mindset starting from the literature study, then field observation goes to data collection. There are primary data and secondary data. Primary data, drill hole data, UTM coordinates, color elevation, log bore lithology, thickness from to, etc. And the secondary data is regional geological map, detailed geological map, detailed topographic map, and asphalt quality data. Then it goes to data verification and then plotting data to base map, which includes topographic modeling, geological modeling, and quality modeling, then goes to model verification, discussion, and the last is conclusion. Data required for asphalt geological modeling. The first is topographic data. This data is useful for knowing the level of the excavated material to be modeled and the terrain condition that will be traversed if mining is carried out. And the second one is geological data. Geological data is useful for knowing geological conditions such as geological structure, rock type, and rock strength, and so on. And the third one is the drill log data. Drill log data is used as additional data for this correlation of lithological data. And then there is outcrop mapping. This data is important data because this data becomes the basic data in 2D or 3D modeling. And last one is the detailed exploration data, which includes mapping data, drilling data, lithology, topographic survey data, data from laboratory analysis or quality test. Then this is the research location map. As you guys can see, this is the province of Sulawesi. And this is where Buton is located. Jump to the next one. The following is data on rock outcrops containing asphalt, which are then plotted on the map. So this is the outcrop data, as you can see here, and this is the outcrop distribution map right here. Then the drill hole data, drill logs, coordinates, and elevation are verified and the plots are mapped. As you can see here, this is the drill holes distribution map and an example of a drill log. Okay, so in order to make a model in 2D, all drill hole lithology data were correlated with an elevation that was adjusted to the topography. Then a cross-sectional line was made that intersects the prospect location. And made a cross-section, the final step is to verify the very resulting model. As we can see together, this right, we can see cross-section, and the left, we can see cross-sectional line location map. The following model verification is carried out using the grid method. It looks like the model is good. So this is the verification geological model with the grid method. Right. So to complete the model that has been built, an isopack map is made for each layer and the contours of its structure are made, making it easier to analyze the resulting model. This is the asphalt deposit model. And on our right side, we got the structure contour layer A, and the left side, we got a map of isopack layer A. And finally, the asphalt quality model is made by statistically analyzing the quality of each borehole and making an ISO quality map. So this is the table of asphalt content testing recapitulation, and this is the graph of moisture content, and this is the bitumen content graph. And this is on percentage, all right? Then the following shows a map of the contour structure of the bitumen quality and grade. On the right, we got the structure contour moisturized content layer A, and the left, we got a structure contour bitumen content A layer. Then we go to the discussion. First is that the lithology that compose the research area is calcareous and calcareous sandstone. The second one is drilling activities have been carried out at 60 drill hole location, found asphalt layer in 52 drill hole location, and 8 drill hole location, no asphalt layer was found. The asphalt layer has a varying thickness, and the distance between drill hole location is plus minus 100 meters. The asphalt layer has a direction of distribution to southwest to northeast, and the slope of the asphalt layer is towards the southeast. And from the correlation between drill holes, it was found that the asphalt layer amounted to 4 main layers of asphalt, where the 3 main layers of asphalt split into 2 layers each of the 3 main layers of asphalt. Based on the isopack map, the thickness of layer A ranges from 0.3 to 56.6 meters. And the very varying thickness of the asphalt layer indicates the fluid nature of the asphalt layer and is influenced by the lithology arranged at each drill hole's location, as well as the existing geological structure. And so that the bitumen content results are fluctuating. Only 3 drill holes location that meet the standard value set for the bitumen content testing are 18%, 24%. So we jump to the conclusion. The first conclusion is that the lithology that composes The research area is called Korea sandstone. Many geological structures are found. The thickness of the asphalt layer will be getting thicker towards the northwest. And the second one is the asphalt layer modeling results show that the general direction of the N1950 to 23503E layer is towards the southwest to northeast, and relatively gentle slope of the layer, which is between 150 to 200 NW, with the thickness getting thinner towards the southeast and getting thicker towards the northwest. And the third one is geological modeling resulted in 4 main layers of asphalt and 6 layers of branching asphalt with a continuous layer model following weak zones and producing varying thicknesses. And then bitumen quality also varies greatly, so that further analysis is needed if you want to proceed to the process of estimating asphalt resources and reserves. So that's all for the presentation. Thank you very much.